Hello and welcome to the Codercy channel. In the second video of my Secure Ktor series, I will show you how to implement a refresh token flow functionality. To not duplicate ourselves, we will use a project implemented in the previous video in which we learned how to secure a REST API with JWT in Ktor. So right now I encourage you to either check out the video or related article on my blog at codercy.com or check out the description for the link to GitHub repository which you can clone and proceed with this tutorial. If you are following me for a longer period of time, then you know that I focus on the practical side of problems. Nevertheless, before we head to the practice part, I owe you a bit of explanation. In the few upcoming minutes, I just wanted to quickly explain the difference between the access token and the refresh token, what is the refresh token flow, and its advantages. Of course, if you feel that this is not necessary in your case, then please skip to the section where we implement the refresh token repository. So let's start everything by distinguishing between access tokens and refresh tokens. First of all, they both play distinct roles in token-based authentication systems. An access token is a short-lived credential which is issued to the client after successful authentication. Its purpose is to grant the client the permission to access some protected resources on behalf of the user. And by the client, we mean here a mobile app, a web app, or any integration interacting with our REST API. Access tokens are designed to be short-lived in order to reduce the risk with compromised tokens. Refresh tokens, on the other hand, are a long-lived credentials that are used to obtain a new access tokens on users' behalf without the need to re-authenticate. So while access tokens are designed for short-lived authorization, refresh tokens provide a mechanism for obtaining fresh access tokens and extending the user session securely. So how does the refresh token flow look like? Well, to put it simply, when a client authenticates successfully, it receives two tokens, the access token and the refresh token. The access token will be used to query our API. If compromised, the bad actor will have a limited time to perform some unwanted actions on behalf of the user, thanks to its short-lived nature. The refresh token with longer expiration time allows to obtain a new access token whenever it expires. This way, the user does not have to provide the credentials like username and password whenever our access token expires. With this flow, we can strike the balance between usability and security. We improve user experience and protect ourselves against unauthorized access. So, what are the pros and cons? When it comes to the advantages, we already covered the first one. The shorter lifetime of access tokens limits the potential impact of token compromise. Additionally, a long-lived refresh token means a better user experience. Simply longer time between asking user for credentials, and trust me, you don't want to specify your username and password whenever you access any website. Lastly, this flow gives us a bit more granular control over refresh token management. For example, we can revoke some refresh tokens. When it comes to the disadvantages, we could call them simply additional complexity. Not only we must implement it really carefully on the backend to avoid any vulnerabilities, but also the storage and transport of refresh tokens must be done carefully to avoid unauthorized access. So to sum up, should we always use refresh token flow in our applications? The answer is, as always, it depends. When dealing with security for our application, we should spend some time to figure out all options that we have on the table. And such an analysis would be way too much for this video about implementing a refresh token flow. So with all of that being said, let's implement the refresh token flow. As a first step, let's open up our Ktor project and navigate to the repository package. Project, src, Kotlin, repository. Right here, I would like to add a new class called RefreshTokenRepository. This one will be responsible for storage and retrieval of refresh tokens. So let's click on the repository package, right mouse button, Kotlin class, and let's call it RefreshTokenRepository. RefreshTokenRepository. To keep our tutorial simple and focus on the Ktor/JWT combination, we will use a mutable map storing a combination of tokens with username in memory. So let's start by implementing it. Private val tokens equals mutable map of string and string. Mutable map of, and as the type, first let's specify the string for keys, and for the values we will be storing strings as well. I would like to introduce two functions here, find username by token and save function. So let's start with the first one, fun, find username by token. It will take one argument of string type, token, string, and it will return a nullable string value equals tokens, and let's search a value by the token. Following, let's add the save method. It will take two arguments, token of string type and username of string type 2. Fun, save, token of string type and username of string type 2. It will return nothing and tokens for the token value equals username. Ctrl+Alt+L to format the code. Excellent. As the next step, let's navigate to the JWT service and let's update it a bit. So, service package, JWT service, and maybe firstly, let's recap quickly what do we have here. So, we inject two things, the application and the user service. Right here we have four properties, secret, issuer, audience and realm, which are read from the configuration file, which you can find in resources, application.conf. Following, we have the JWT verifier, which we use to verify JWT tokens that are sent to our REST API. After that, we have create JWT token function, which takes the login request as an argument and returns a string value with JWT token if everything is successful or a null value otherwise. Lastly, we have a custom validator and a bunch of private functions. The first thing I would like to update here will be replacing the user service inside our constructor with user repository to avoid circular dependencies. So let's replace that with user repository of type user repository. Excellent. Right now the code will not compile. Nextly, I would like to modify the create JWT token function so that it will be only responsible for creating JWT tokens, and it will take the username and the expire in as the integer value. So firstly, let's update the arguments. The first one will be username of type string, and the second one will be expire in of integer type. Instead of returning nullable string, I would like this to return always non-null value. Nextly, I will get rid completely of everything except this part. So we can go this way, this, and lastly get rid of that. Ctrl+Alt+L to format the code, and we can see that with claim function does not compile because we don't have the found user. So the only thing I need to do here will be specify the username. And lastly, let's make use of the expire in. So instead of providing a hard-coded value here, I would like to add the value that is sent as an argument here. Expire in. Excellent. Additionally, I can make this function private because as the next step, I will introduce two functions, create access token and create refresh tokens. So let's make this one private and let's introduce two functions I mentioned. Fun, create access token. It will take the username of type string and return non-nullable string. It will invoke our create JWT token function and provide 3,600,000 as the second argument, which translates to 1 hour. Username 3,600,000. Next, let's add the function create refresh token. Fun, create refresh token. Again, this one will take the username of type string and return the string value. String, return a string value. Create JWT token. Let's specify the username. And this time I would like to provide 24 hours as milliseconds, which will be 86,400,000 and 3 zeros. 1. Ctrl-Alt, +L, excellent. When we scroll down a bit, we'll see that the code will not compile right now. We were using the user service, which we already removed, so let's replace this one with user repository. User repository. Wonderful. And as the last thing, I would like to introduce the audience matches function, which will be a public function, which we will use later. The only responsibility of this function will be to compare the audience property with the audience sent to this function. So fun, audience matches, audience, string value, boolean equals this audience equals to the audience sent as an argument. Excellent. At this point, everything compiles and we can update the routing layer. So as the next step, let's navigate to the routing package and let's add a bunch of request and response classes. The first one will be the RefreshTokenRequest. So, navigate to routing, request, new. This will be a data class. So scroll down a bit right here, RefreshTokenRequest. Again, we must mark that as serializable when working with Kotlin, and this one will have only one property, token of string type. Val token string type. Nextly, let's navigate to the response package and add the authResponse class, which will serialize the authentication response. So, right mouse button, Kotlin class, data class called authResponse. Again, let's mark that as serializable and let's provide two fields, access token and refresh token. Val access token string type and val refresh token of string type 2. So this field will be populated with access and refresh token when we authenticate users successfully using its username and password. Finally, let's add the refresh token response. New Kotlin class / file refresh token response, and I forgot to mark the data class, so let me convert that to data class. Let's introduce a constructor, mark that as serializable, and let's add the token of string type. Following, let me navigate to the routing KT file right here, and instead of injecting the JWT service, we'll inject only user service. So let me get rid of that. And for the auth route, I would like to provide user service. We can see that the code right now will not compile. So let's hit Alt + Enter and change the parameter. Of course, with that done, let's update the auth route. So hit Ctrl and keep it pressed and click on the auth route right here. You can see that although the type was updated, the name not necessarily. So let me hit Shift + F6 and call it user service. At this point, we can see that the code will not compile. So firstly, let's get rid completely of this line, and I'll introduce the auth response and the function called authenticate, which we will later add to the user service. Val auth response. This will be auth response nullable equals user service dot authenticate, and we'll simply provide the login request there, login request. Don't worry about this right now, we'll get back to that later. Auth response let, and if everything is working successfully, I would like to simply return the object, right, which will serialize to the JSON. Auth response, wonderful. Following, let's add a new endpoint to refresh our tokens, right? So let me scroll down a bit, hit enter, and let's call it post /refresh. So whenever we call our API to /auth/refresh endpoint, it will be handled by this function. What we need to do here will be, firstly, we will read the JSON value into the refresh token request instance. Following, we'll simply invoke the user service and refresh our token. Lastly, if everything is successful, we'll return the refresh token response or 401 unauthorized otherwise. So let's implement that. Vol request, and as you remember in Ktor, we invoke call.receive in order to read the JSON payload into the instance of object. RefreshTokenRequest is the class responsible for delivering this data. Nextly, in order to generate a new access token, which will be a string, we'll invoke the RefreshToken function in UserService, which does not exist yet. So, vol new access token equals UserService dot refresh token, and I would like to simply provide the token value there. So let's read the request token string value. And as this function does not exist yet, let's explicitly specify that the return type will be a nullable string. So following, if the string value is not null, it means that we successfully obtained a new access token and we can return that to the user. New access token dot let call dot respond, and I would like to respond with refresh token response class. Refresh token response, and let's provide it. Otherwise, I would like to respond with 401 unauthorized. Call dot respond, and right here the message, instead of null, http status code dot unauthorized. Wonderful. So as the next step, we must simply update UserService. We can do that easily with IntelliJ, so click on the red authenticate right here, Alt plus Enter, create a member function. Hit Enter a few times and IntelliJ will automatically insert the skeleton for our function. Let's get back to the root and let's do the same for refresh token. Alt plus Enter, create a member function, press Enter a few times and the same will happen for this function. So after our changes, the authenticate function will be responsible for fetching the user by username, comparing whether the password is successful, and if everything is successful, then we will create access token, create refresh token, persist it in our refresh token repository, and lastly return the auth response or null if this is not successful. So as the first thing, let me scroll up a bit. And right here, we'll add two things. The first one will be JWT service, and the second one will be refresh token repository. So let's hit enter, private val JWT service, and private val refresh token repository of type refresh token repository. Excellent. Alt plus enter to import, and let's scroll down to the function. The first thing I would like to do will be to simply read the username from login request. So val username equals login request dot username. Nextly, let's try to find the user using the user repository. Val found user equals user repository dot find by username, and let's provide our username. Of course, we must remember that the repository can return null in this case, so we'll handle that in a moment. Now, as I mentioned previously, I would like to return the auth response if everything is successful. So, firstly, I would like the found user to be not null and the password to match. Return if found user is not null and the password of our found user password equals to the login request password, then I would like to proceed. Otherwise, we'll return null. As mentioned previously, firstly, let's generate access token, and we will use already prepared methods to that. Vol access token equals JWT service access token. Create access token. We must provide the username. Similarly, let's prepare refresh token. Val refresh token equals JWT service dot create refresh token, and let's forward the username there. Of course, we must remember to persist the refresh token in our repository. So the next thing, refresh token repository dot save refresh token we must specify the refresh token value and the associated username. So lastly, I will simply return of response object, and as the access token, I will specify generated access token. For the refresh token, similarly, refresh token value. Ctrl-Alt-L. At this point, everything compiles successfully. Later, we'll test our functionality, but before we do that, let's implement the second function, refresh token. Inside this function, firstly, I would like to verify refresh token whether this is a valid JWT value. Nextly, we'll try to find the persisted username by the refresh token value. And if we successfully find the persisted username and decode the refresh token successfully, then we'll follow up with the rest of the logic. So maybe to not complicate at this point, let's start with decoded refresh token. Val decoded refresh token equals, let's introduce a new function to improve readability of our UserService class. Verify refresh token, and let's provide the value there. Token. Again, let's use a shortcut, Alt+Enter, create a function verify refresh token, which will return the decoded JWT instance or null. Coded JWT instance or null. In order to obtain the decoded value, let's use the JWT service and JWT verifier. So vol decoded JWT of type decoded JWT equals, right now I would like to go with try catch JWT service JWT verifier dot verify. We can use this method to verify our token, right? Let's provide it. Catch exception. If we catch an exception, let's simply provide a null. Again, we can introduce a method, and there is an interesting shortcut for that. You can select this try catch, Ctrl+Alt+M, and introduce a new function. You should memorize that. This is really helpful when working with IntelliJ. So this function will either return the decoded JWT or a null value. So as the last thing, I would like to simply verify whether the audience matches. So return decoded JWT, which at this point is nullable. Let's hit enter. Vol audience matches equals JWT service dot audience matches it. Let's go to audience and let's get first value. Lastly, if the audience matches, I would like to return the decoded JWT, otherwise null value. So if audience matches, I would like to simply return decoded JWT value, otherwise a null value. Ctrl+Alt+L. So far, so good. So as the next step, let's get back to our refresh token function and let's obtain the persisted username by the token value. So val persisted username equals refresh token repository dot find username by token, and let's provide the token value. Now, if the decoded refresh token and persisted username are both not null, we'll proceed. Otherwise, let's return a null value. Return if decoded refresh token is not null and persisted username is not null as well, then we'll proceed. Otherwise, let's return a null value. Following, I would like to use the user repository to find user by username. Additionally, from our decoded refresh token, we'll get the username claim. And when both found user is not null and the username from refresh token equals to the username of found user, then we'll create a new access token finally. So as you can see, pretty a lot of things need to be done before we obtain a new access token, but this is all necessary to cover a lot of vulnerabilities and cases. So as I mentioned previously, let's start with finding a user. Val found user repository equals find by username, and as a value, let's provide the persisted username. Nextly, let's obtain the value from refresh token, val username from refresh token equals decoded refresh token get claim, and right here we can specify the username claim. Lastly, if found user is not null and username from refresh token equals found user username, then we'll invoke the create access token function, JwtService.create access token for persisted username. Otherwise, let's simply return null. Ctrl-Alt-L, let's see what's going on here. Operator equals cannot be applied to claim and string. Oh, yep, I forgot about one thing. Get claim as string in order to obtain the username claim as a string value. So at this point we have almost everything we need to run our application and verify it with Postman. Nevertheless, let's get back to the application.kt file and let's adjust the code. Right here we have updated UserService, so right now UserService takes user repository, JwtService and RefreshTokenRepository. So JwtService, we'll start with that, requires user repository. Excellent. UserService requires user repository, JwtService and RefreshTokenRepository. So we must add first RefreshTokenRepository equals RefreshTokenRepository. Wonderful. And let's update UserService, JwtService, RefreshTokenRepository. Lastly, we must update configure routing. So if I remember, correctly, UserService is the only required parameter here. So let's get rid of JwtService. Ctrl-Alt+L, format the code, Shift+F10 or the green icon right here to run the application. Wonderful, we can see that this is working and serving our requests at localhost 8080 port. Let's open up Postman then. As the first thing, let's create some user. I'll call it some username and he will have a password. We can see 201 created. Wonderful. So as the next step, let's go to the auth endpoint and let's obtain the token for some username and password. Excellent. At this point, we can see that we have not only the access token, but refresh token too. Let me copy this value, Ctrl+C, go to the get all users, hit send. Firstly, we should see 401 unauthorized because the token right here is expired. This is good. Let me replace that with a new value and see that everything is working as expected, right? So following, let's add a new endpoint for refresh token of Ctrl+C, Ctrl+V, and we have this auth copy /auth refresh. As a body, we will send the token value. Token equals, and right here. Let's get back and get the access token and let's see what's happening here. Let's try hit send 401 unauthorized, which is correct because this is the access token. In order to get a new access token, we must use the refresh token value. So let's copy the appropriate one, get here, Ctrl+V, and let's hit send. Wonderful. We can see that we got the token value. The last thing we must do will be to simply verify whether this is working with a new token value. So this is the old one, 200 OK. Let's start with a new one, similarly 200 OK, which indicates that our refresh token flow is working as expected. And that's all for this video, in which we learned how to implement a refresh token flow functionality in Ktor. As always, in the description for this video you can find a link to my related blog post where you will find a full source code. Thank you for being here, and right now I would like to invite you to the next video, in which we'll learn how to implement a role-based access control in Ktor app. Don't forget to leave a thumbs up, subscribe, and see you in the next video. Bye.